Hello everyone, welcome to the channel. Today we will be architecting a production-like environment in AWS. This is a general setup that is done whenever you create an AWS account and when a new production-like environment is to be set up on the premises. We will start by creating a VPC followed by subnets and many small and big components which are needed to be set up for the entire environment to be up and running. If you follow this video till the end, you would proudly be able to say that you have experience in creating and setting up production environments in AWS. We will be taking care of high availability and would also be testing our environment by creating EC2 instances in both the public and private subnets, and also will be testing internet access on them. Along the way, we will be troubleshooting a lot, trying to fix issues, errors that come along. With this, I hope you will be able to gain some mastery on AWS, which should be able to help you clear interviews and help you breeze through new environment setup tasks at your work. So without wasting much of our time, let's jump into the demo. So as you see, I am logged into my AWS console and I am currently in the Mumbai region. I will switch my region to US East 1, where I would be creating our resources. If you look into the VPC, I would go into the VPC section. I don't have any VPCs as of now. For the purpose of this video, I have already deleted the default VPC that was there in my region. If you're wondering if we can create a default VPC after it is deleted, yes, you can create it. All you have to do is click on create default VPC and that should give you the VPC back. For the purpose of this course, to make things pretty much clear, I would be getting rid of the default VPC, and I also strongly recommend everyone who is learning AWS for the first time to delete the default VPC and create everything afresh. To start with, we would be creating a VPC, and I would create the VPC as P00 VPC01. I've just given a name CPB00 VPC01, and I'll select the CIDR range as 10.10.0.0/16. We are not going to use IPv6 in this demo, so we are strictly adhering to IPv4 standards, and the tenancy that I would be using for the VPC is default. I create the VPC, and as you see, the VPC has been created. And as you see, this is not a default VPC because we have created it manually with us. The next thing that I would do is create my subnets. For that, I need to select the VPC inside which I would be creating the subnets. I'll be creating two subnets, that is subnet 1A, and I would be giving in the availability zone as 1A. The subnet range I would be selecting as 0.0/24. So that would give me 256 odd IP addresses. Once this is done, I would be then creating another subnet which should be in 1B. This is for high availability purposes. So once this is done, so what I'll do is I'll say subnet 1B, and I would select the availability zone US East 1B, and the CIDR range would be 10.10.1.0/24. I click on create subnet, and if you see, I should be able to create both the subnets. So I am now able to see both the subnets being created over here. The next thing that we would be going to do is creating an internet gateway. So let's look at the internet gateway. So there are no internet gateways as of now in my region for this account. So I would be creating one internet gateway and giving it the name CPB00 IGW. If you see, I am following the standard naming convention for all my resources. This is one best principle that we would have to do when creating resources in AWS. The next thing that I would be doing is attaching this internet gateway to the VPC that we already created. So this is the VPC and I've attached this internet gateway to it. Once the internet gateway and both the subnets have been created, the next thing that we would have to do to set up the account is we should be creating a route table. Though we already have a main route table associated in this VPC, because whenever you create a VPC, along with the VPC there are two more things that get created automatically. Those two things are a route table and a network access control list, or that is the main NACL, and a main route table is created. I strongly recommend you not to use the main route table in the main NACL and go ahead and create your own route tables for the routing purpose. I'll give this name as route table and I would select the name of the VPC that we created and I'll click on create route table. The next thing that we need to do is edit the subnet association of this route table. So I would be associating both of these subnets with this route table, and the next thing that I would be doing is editing the routes to the internet. So I provide a route to the internet via the internet gateway. Now here is an interview question. Any route table which has been assigned to the internet gateway would then become a public route table. So what I'll do is quickly go ahead to my setup and I'll rename this as public route table. Now any subnet which is associated with the public route table would then become a public subnet. So I would then call it as CPB00 pub sub 1A and the other one would be pub sub 1B. Now that we have both our public subnets created, the next thing that we should be doing is we should be editing the subnet settings for our public subnets and make sure that auto assign public IPv4 addresses is enabled on them. I also am allowing the DNS A record, enabling resource name DNS A records and on the launch. So we are basically adding two features to it. The next subnet is this. So I'll also be doing or performing the similar changes on this subnet as well, and I would also be allowing this, and this should be done. Now that both the subnets have been created, I also have the route table created, which is giving the route to the internet as IGW and the internet gateway in place, right? The next thing that I should be doing is going ahead and creating my network access control list. If you see, there's also already a default NACL as we discussed earlier, but this NACL is allowing everything outside. And I definitely don't want to use a default NACL because this is not industry practice and also not a good option from a security standpoint. What we'll be doing is creating a new NACL, so that's there at the extreme right. I would be calling this as the public NACL because this would be associated with the public subnets that we have just created now. I'll be creating the NACL, and once the NACL has been created, the next thing that I would be doing is adding in some inbound rules. So we would be testing our application, or we would be testing our setup by launching Linux servers, and for that purpose I am allowing it from the entire internet as of now. So once this inbound rule is done, so what I'll also be doing is I should also be changing outbound rules, but as of now I would not be adding any rules. The next thing that we need to do is change the subnet association for this NACL. So we need to associate both our subnets with this NACL, and then we can now go ahead and create our EC2 instance. So next thing that I would be doing is creating an EC2 instance in my US East 1 region. For this, I would be going into the EC2 dashboard. I will be clicking on launch instances. And the very first thing that I do is give the name for the instance, and I say Linux, and I call this as a public instance. The AMI that I'm selecting would be Amazon Linux, and the instance type I would be selecting is T2 Micro. I would be trying to see if I can get use of an existing key pair, that is CPB00 US East 1, and the subnets that I am creating this is in the public subnet, and if you see that the auto assigned public IP address has been enabled by default. I'll not be making any more further changes. So what I'll be doing is allowing the SSH on the new security group that is being created. So I'll be allowing this, and we would be launching the instance. Now that this is done, so what I should be able to do is go to my EC2 instance, get in the public IP address that is assigned to the EC2 instance, and I should be able to connect using that public IP address. So I'll just copy this. We'll just have to wait for this EC2 instance to come into the running state, which generally should not take a lot of time. So you see that the instance is already in the running state. I would then connect to my terminal. The terminal that I am using is MobaXterm. I would be starting a new session. I would be choosing SSH. The host name is this. I would specify the username as EC2-user. I go to the advanced settings, and I would select the private key. So the private key file would be selected from this, and I am currently using CPB00 US East 1.10. I'll just say OK, and so if you see, if I try to connect to this EC2 instance, I'm currently not able to connect to this EC2 instance because this would be timing out. The other way to pictorially see if we are able to connect to the EC2 instance or not is by providing the details. So that is CPB00 US East 1.pem, and you would see that it is currently timing out. The reason why this is timing out is because we have not provided any outbound rules as of now. So the outbound rule that should be added over here is called as ephemeral ports. So I should be providing 1024.265.535 as the ephemeral port for allowing the traffic on this NACL. If you guys are interested to know what ephemeral ports are, I could definitely make out a video and post it on the channel. Do let me know if such a video is needed in the comments section. So as you see, we are able to connect to the EC2 instance. The next thing that I would do is elevate my privileges and then try to connect to google.com to see if I am able to connect to the internet or not. Now the curl request that we have done should be giving us an output which is similar to the one that I do here. So we should be getting a similar response saying that this has been moved to www.google.com. So this is the one that we should be getting. But as you see, we are not actually getting any response from the curl command that we have run on the server. In order to fix this, what we have to do is allow two separate rules on our NACL. The first rule would be the outbound rule, which is actually going in with HTTPS, and I should be allowing over the internet. The other rule that I should be adding is an ephemeral port range should be allowed inbound in my NACL. So I would be doing this as 1024.265.535, and I should be allowing this to be coming inside the NACL. Now if you see, I do the same curl command, and it's still not working. Now the other reason why this is not working is, So there was a small typo, so we should be actually trying with HTTPS, and as you see, this is now moved to the channel. To quickly demonstrate that it still works, it doesn't work if we remove the 443 rule. So I'll just remove the rule and quickly do a curl again with the HTTPS, and you see that it still doesn't work. So that actually proves that the outbound rule should be having a rule that says it should be allowing traffic on HTTPS. I just allow it, and you should see that as soon as it's allowed, the traffic should be able to establish, and we should be getting the response. Now let's try to go further into the architecture. So what we have already done is we have successfully been able to create a VPC. We have created two subnets, and we have associated the subnets with a route table which is having the route to the internet via the internet gateway. Now, because of this kind of a setup, that route table becomes a public route table and the subnets become a public subnet. Now that the public subnet has been tested, we are able to connect to the internet. So that's a win-win situation that we are in. What I'll be doing next is creating two private subnets, and then would be testing internet access very soon. So for this, what I'm doing is CPB00. I'll be creating private subnets. So that is private subnet 1A. I would be selecting the availability zone as 1A, and the CIDR range that I would be selecting is 10.10.2.0/24. Now that this is done, I'll add another subnet. So that is CPB00. That would be private, that is subnet, and that is 1B, and I would be selecting 1B over here, and the CIDR range that I should be selecting is 3.0/24. Now that is done, so what I'll do is create both the subnets. So with this action, we would actually be creating two subnets. Now that these two subnets are created, we will be performing the similar action. So what I'll be doing is creating a private route table. So I'll call this as private RT, and I'll select the VPC over this. The next thing that I would be doing is the subnet association. So I would be associating the subnets. Both the private subnets would be associated with this particular route table, and that should be done. The next thing that I am gonna do is create an NACL. This would be a private NACL that would be created. So I'll say 00 private NACL, and I would be selecting the VPC over here. The next thing that I should be doing is associating this private NACL with the other subnets that are left out. So both the private subnets would be now associated with this NACL, and this setup is done. If you see, both the NACLs are neither, so the private NACL is neither allowing or the inbound rule or outbound rule in any which way. So the first thing that I would do is enable the inbound traffic. I'll say rule number 100 would be allowing all traffic from within the VPC at least. So I'll select the VPC CIDR range, that is 10.10.0.0/16, and I would also be doing a similar thing wherein I would be allowing all traffic to go within my VPC on the other side of the network. So that is again a 10.10.0.0/24. I'll click on save. The next thing that we would be doing is let's create an EC2 instance in the private subnet, and then try to test if we are able to connect to that EC2 instance or not. So the first thing that I'll be doing is launching the EC2 instance. I'll say this to the CPB00 private, that is a Linux server. I'll selecting Amazon Linux 2 as the AMI. I'm not changing any other stuff over there. And the other thing that I would be selecting is CPB00. I would then be changing the subnet to point to a private subnet of mine. And if you see, the auto assign IPv4 address has been disabled as of now. Now I'll be still creating a security group which is allowing the traffic from the entire internet. This is just for the purpose of the video. Though from a security standpoint, it's not recommended that you allow inbound rules from the entire internet for the security groups. So I already have a private IP address, and the only way in which I can connect to this is using SSH tunnel, or what I can do is log into the public server first, which is the Bastion server, and from here I can connect to the private EC2 instance. So let's try to see if I can catch hold of my SSH config. Yes, I can. So what I'll do is try to open my SSH config in VS Code, and what I would be trying to do is create my config. Probably have to see if it opens it. Yeah, it opens it now. So what I'll do is get rid of the older one that was created, and I'll just change the configuration from my existing one. So I already have a configuration which says a bastion. Now this bastion is long gone, so what I'll do is change the host name of that to the physical or the public instance that I already have in my VPC. That is this is the IP address that I have. The port number still remains the same, and what I would be doing is I definitely need to change the key with which I would be logging in. So the key name should be able to find it over here, and I would just append .pem over there. The next thing that I have is this. So what I'll be doing is I will be appending my private IP address over here. The key remains the same, so we have not changed the private key for logging in, and this should be it. So I can test my configuration now. So what I can do is just say SSH bastion, and I should be able to SSH into my current public EC2 instance, which I also call it as bastion or jump host. And if you see, I am still able to do a curl for google.com on this, so it works absolutely fine. Now what I can do is also SSH. I should also be able to SSH into my private EC2 instance, which is this. I just copy the name, and this should allow me to SSH into the server. Now we would have to see if we are allowed into the SSH or not. If not, then we would have to troubleshoot our way down to try to see which firewall rule is actually not enabled to allow us the setup. So as you see, we are not able to SSH into the server. So let's quickly go into our NACLs and try to see what exactly is happening. As per the architecture diagram and the flow of the internet, flow of network, right? The request is first going into the public EC2 instance or the bastion host, and from the bastion host, this actually goes into the private EC2 instance. So what I will be doing is I would by default be allowing all traffic from our VPCs to flow within. So what I'm doing is allowing all traffic to come from within the VPC, and I would also be enabling all traffic to go out of this VPC for the destination to be within the VPC. So I just said this, and I just am appending the VPC CIDRs in the destination as well. As soon as I hit save, right, and let's try to connect again. Let's try to connect again and see if we are able to connect to the EC2 instance or not. So as you see, you are getting some response, and I am currently logged into the EC2 instance, which is there in my VPC. We could check the IP address. So the IP address comes out to be 10.10.2.234, and the IP address that I have got for my private EC2 instance is 10.10.2.234. The next thing that I would be doing is trying to see if I can do a sudo su privileges. I'll try to clear the screen, and then what I'll be doing is doing a curl https google.com. Now if you see, we are not able to connect to the internet using this. This is actually happening because the route table which is associated with these subnets, right, is not actually having any details about the route to the internet. Now for a private subnet or a private route table to have its route to the internet, we should be creating NAT gateways. A NAT gateway is needed for connectivity between the private subnets and the internet. So what I'll be doing is CPP00, I'll say NAT gateway, I'll just say 1A. I am only going to create one NAT gateway, but in ideal scenarios, you should be actually having two NAT gateways in two public subnets. But because this is just a training video, I am just limiting myself to one NAT gateway, which is created in the public subnet 1A. Now NAT gateways always need a elastic IP to be associated with them, so I'll click on allocate elastic IPs and click on create NAT gateway. Now once I do this, so this might take a few seconds for the NAT gateway to be created. So as you see, this is still being created, so the state is pending. I would in the meantime go into the route table, and here in the route tables, in the private routes, for the private route table, you could edit the routes and add 0.0.0/0, and here you could select the NAT gateway and the NAT gateway that we created. You click on save changes, and you would see that the NAT gateway is active. That means that the NAT gateway should also now be in created state. Yes, it's still trying to figure out its way. We'll probably wait for a few more seconds before it creates itself. Now let's also look at the NACL and try to see if we are allowing all needed permissions in the private subnets. I'll go into the private NACL, and the first rule that we need to check is, are we allowing outbound traffic to the internet on 443? As you see, we are not. So what I'll be doing is I'll be adding HTTPS, and this should be allowed over the internet. The next thing that we should be making sure that we are allowing is again the ephemeral ports. They should be allowed inbound. So what I'll be doing is port number 200 should be allowing 1024 to 65,535 as from the internet. We'll again give a sneak peek into the NAT gateway and see if it is available as of now. Yes, it is available. I'll quickly double check my route table and see that it is also having the route to the internet. And now that we have also added the stuff, what I should be able to do is, if you do a curl for HTTPS, I should be able to get hold of the internet connection. You could simply try with a trial and error method. So you could always, once everything is working right, if you want to learn deeper, what you could always do is remove one rule at a time and then try to see if you're still able to connect to the internet. And that way you would be able to determine which rules are the most needed for connecting to the internet or for enabling connections to the internet. So as you see, we are not able to do anything once I remove the ephemeral port ranges. So that clearly shows that ephemeral port ranges are very much needed if you want to connect to the internet from your private EC2 instance. As soon as I add that, you should be able to connect to the internet, because in the backend the curl command is gonna retry multiple times unless it connects to the internet. So as soon as the firewall rule has come into effect, so what you are able to now do is connect to the internet using this. So this is what the mini architecture looks like. So now you already have a full-fledged VPC, a production-like VPC. So I'll give you a quick tour. So what we have created so far is a VPC. So the VPC has having a CIDR range of 10.10.0.0/16. I have 4 subnets in my VPC. 2 of the subnets are public subnets and 2 of the subnets are private. The public subnets has the CIDR range of 10.10.0.0/24, 10.10.1.0/24. Private subnets are with 10.10.2.0/24 and 3.0/24. What we have also done is enabled auto assign public IP settings on the public subnets. So that setting has been enabled. So auto assign is enabled on the public subnets, whereas in the private subnets it is not enabled. Next thing we did is we created 2 route tables for each public and private subnets. For the subnet which we wanted it to be public, so we actually attached the internet gateway with this route table, and the subnets in which we wanted it to keep as private, we attached the NAT gateway with that route table. Now obviously the route tables are associated with the subnets, and that's how the association is done. The next thing that we created is NACL. So we created 2 NACLs, one a public NACL and a private NACL. The inbound rules in the NACL after all our troubleshooting looks like, so we are allowing port number 22 to come inside from the entire vault, number 1. We are allowing ephemeral ports to come from the entire vault, and we are allowing all traffic to come from within the VPC. Similar thing would be seen in the public in the outbound of the public NACL, that is 1024 being allowed for the outer world, 443 being allowed to the outer world, and all traffic to the VPC. Similar thing happens in a private NACL. This is the outbound rule. We have all traffic going to the VPC. This rule shows not a 16 but a 24. We have been lucky that it worked, but it should ideally be a /16. The HTTPS traffic is also going outside. Similar thing inbound, I have allowed all traffic to come from within the VPC, and only the ephemeral ports have been allowed in. Now these are the minimum configurations that are needed for us to set up the production like environment wherein you are allowing internet access from both public subnets as well as private subnets. With this, we come to the end of the mini project, right? So if you are able to implement this without looking at an architecture diagram or without looking at any documentation or any of a video, you should feel confident enough that you are in the top brass of AWS engineers or architects who are able to create high available networks which actually work. With that, we come to the end of this video. Thank you so much for watching till the end. If you're not subscribed to the channel, please subscribe to the channel. Thank you so much for watching. Please have a great day.